Hi, this is Erwin Lazar, Vice President and Service Director at Nemertes Research, and welcome to our webinar entitled Next Generation Cybersecurity Architecture, presented by Nemertes CEO and co-founder John Attil Johnson. A replay of this webinar will be available in our channel shortly following the session. Today's webinar consists of an interactive presentation and a moderated Q&A period. Please feel free to submit any questions you may have along the way, and we'll do our best to answer all of them. With that, let's go ahead and get started, and I will turn it over to Jana.
Great. Thank you so much, Erwin, and thanks everyone for being on this presentation. As you can see, we're going to be talking about next generation cybersecurity architecture. So first, I'm going to talk a little bit about Nemertes and what we do, highlight some of our ongoing and upcoming research that you can be a part of, and then we'll jump into the topic at hand. What is a next generation cybersecurity architecture? What should go into it, and why do I care? And then we talk a bit about some key vendors and technologies that can play a good role in this. We'll tell you a bit about how Nemertes can help, and then do a quick wrap up and leave time for Q&A. So we are a global research and strategic consulting firm that analyzes the business value of emerging technologies. You may be thinking, what does that actually mean? Just a little bit of background. I started the company back in 2002. My previous role was as Chief Technology Officer for a global engineering company. And in that role, I found that there was a lack in the market because there wasn't anyone looking at emerging technologies and the operational and business impact of them. In other words, if I had to send a bunch of engineers out to build a next generation infrastructure for someone, what were the technologies coming down the pike that they needed to use? And what was the business impact and the operational impact of these technologies? So I reached out to a partner and started the company so that we would constantly get new information about emerging technologies by talking to the people using those technologies. We've been in business and client-funded throughout business since 2002, and we do research in a ever-changing portfolio of emerging technologies, including cloud and networking, cybersecurity and risk management, digital customer experience and transformation, IoT, next-generation endpoints, and unified communications and collaboration. So that's the kind of work we do. We do quite a lot in cybersecurity, and we do a lot of consulting work with very large enterprise organizations in cybersecurity, and that's where most of the information you're going to see comes from. So just before we jump into the topic at hand, I just want to remind everyone, Erwin will touch on this again a little bit later, but we have a couple research projects in progress. First and foremost is the Cloud and Security Research Study, where we got a lot of this information. We are recruiting now. Please click the link in the Attachments tab if you wish to participate. Participants who must be qualified IT executives will receive results, a maturity model, scorecard, and other great stuff. We're also going to launch next month the IoT research study, so Internet of Things research study. Again, you can subscribe to that and participate in exchange for getting some really good stuff at the end of the study. So go ahead and click on that in the attachment when you get a chance, and now let's get started. So first, we have to talk a little bit, before we can talk about a cybersecurity architecture, we really need to talk about architecture in general. And this is actually an important point because many times our customers and other large enterprises will say, why do I need an architecture? I just need functions, and I need those functions fulfilled. Why do I need to spend a lot of time developing PowerPoints that nobody's ever going to look at? Which is honestly how a lot of IT organizations think about an architecture. So particularly with cybersecurity, I want to touch on a couple key architecture fundamentals. First is what a cybersecurity architecture is. Like any other architecture, it's a high-level view of capabilities required to deliver a function or service. It includes both the functional components and the interconnections between the functional components. The joke here is for those old enough to remember the dot-com boom, companies would always start their venture funding pitches with the bubbles and arrows charts. Here are the things, and here's how the things talk to each other. But that's actually, as silly as it sounds, it's actually an incredibly important piece of an architecture. You don't just say, it's not just a checklist of functions, but it's also a visual and system-wide description of how those functions interact. And the key thing is it really needs to capture in some way all relevant requirements and design principles. So for example, if you have a cloud architecture, you need to show all the capabilities of cloud that you're planning to take advantage of, whether it's software as a service, infrastructure as a service, or platform as a service. So it really needs to, it's a high-level functional view. I like to think about it in my years of design engineering. I would start with a box and gazintas and gazoutas, and then decompose the box into lots of smaller boxes until I figured out exactly how to accomplish the main goal I was trying to set up. And that's really what an architecture needs to do. Why do you need an architecture? First and foremost, it serves as the foundation for delivering your roadmap. Once you have the architecture, you're not going to go to the store and buy all the pieces and hook them all up and then have your implementation. You will, over time, procure various products and services, integrate them, test them, roll them out into production, and then build on them to complete the architectural vision. But in order to start with in order to build that roadmap, you need to know what it's supposed to look like in the very end state. So in a sense, it becomes the end state of that roadmap that you have, so you know what you're doing when. More importantly, and this is really key, your architecture helps you make decisions about whether or not to go with a particular technology or vendor. This is really important, and I actually sat with a very, very large Fortune 50 company not too long ago, and they looked at me and they said, wow, we never really thought about the architecture as providing the framework against which we're making decisions. But it is. It should be. If your architectural principle is, for example, cloud first, and somebody wants to deploy an on-prem application, you may say, no, we only deploy on-prem applications if they meet the following criteria, if we can't do it in the cloud or whatever. And that allows you to very quickly cut off discussion that sometimes gets too far down in the weeds, so people are arguing and debating about functional requirements. Well, but this one has better functionality. Yeah, but our architecture is cloud first. So we're not going backwards, we're moving forwards. From a business value perspective, this is a huge challenge, and I'll be talking more about this actually next week when in New York I'm at the Wall Street Technology Association's Enterprise Architecture Seminar. One of the big questions that people ask is, why do I have an architecture? What's the business value? First of all, it's faster deployment because, as I mentioned, you're spending less time fighting about tools and technologies because you've developed the framework that allows you quickly and easily to decide among them. It also means that you can have a more accurate deployment. You're going to have fewer mistakes because if you know that two components have to integrate together, that's a design criterion from the very beginning. You make sure that integration works before you move forward, and you don't end up at the end of the road going, oh gosh, these two things had to talk to each other. What were we thinking? So there are good reasons to have all this. All right, you may be thinking, great, thanks, Jana, for the Architecture 101. Now let's talk about cybersecurity. Last point. Sorry about that. We have quantitatively measured in our research studies that a very, very clear bellwether of success in terms of operational cybersecurity metrics is having an architecture. That sounds goofy, but if you are looking to improve your operational metrics and you don't have an architecture, you probably want to build one. So that's the last good reason to have an architecture. What's interesting is, despite all these good reasons, most of the cybersecurity environments we look at today, they may say they have an architecture, but actually they don't. They have lots of architectures. They might have a network security architecture. Okay, we've got a centralized next-generation firewall. We're Palo Alto. That's what we do. That's our architecture. Well, okay, but how does that integrate into your compute security? Well, we haven't thought about that. They may have a compute security architecture. They may have an application and data security architecture that talks about how applications are protected and data is protected, but only applications and data on-prem, because that's where the architecture was developed. They may even have a DevSecOps architecture, although that's actually questionable. They may also be, building out security functionality for UC and social media security. They typically have a silo that focuses on mobile security. Oh, those are the guys that buy the MDM. That's mobile security. We don't talk to them. We in cybersecurity don't talk to the mobile folks. IoT security. Most organizations we work with do not yet have an IoT security architecture, much less any integration between the IoT security architecture and the cybersecurity architecture as a whole. And cloud. Everyone has to rethink the cybersecurity architecture in the context of cloud, and what we see is most organizations are actually thinking of cloud as its own silo. So there's security, and then there's cloud security. And all of this fragmented and overlapping approach to security leads to disaster. We've lately started doing projects where essentially companies have very good operational metrics on security, but they're also spending way too much to do the same things. So they may be implementing the same functions in 5 or 6 different devices, which means they have to have 5 or 6 different teams of cybersecurity specialists each up to speed in their particular vendors, all doing the same thing, and they don't have budget, resources, or time to roll out things like CASB, which we'll talk about in a little bit, cloud access security brokers, to protect their on-cloud resources. So it really is a problem not having this overarching cybersecurity architecture. Okay, so let's talk about how you go about building one. What, in its fundamental essence, is a cybersecurity architecture? It's basically about how you combine policy and knowledge with enforcement. What do I mean by that? Policy is the definition of, and we'll talk about each of these in greater detail in just a second, but policy is all about what should be happening in your environment. Knowledge is knowing what is happening in your environment. And enforcement is basically bridging that gap. If something is happening in your environment is not what should be happening in your environment, you leverage enforcement to make sure it is happening. These 3 are the fundamental components of a cybersecurity architecture: policy, knowledge, and enforcement. Now, you may be looking at this and saying, great, Jana, I'm really happy because I have a cybersecurity policy. We have some great, tools for knowledge, and we're doing a terrific job enforcing things. Well, yes, but no, as we'll talk about this, because the real challenge with cybersecurity is integration, 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 and that's kind of the key takeaway from some of this as you go about putting together your architecture. So let's talk in detail about each of these. What is a cybersecurity policy? Well, it really is, at its very basic level, it's a definition saying that users and applications can only do what they're supposed to do. Now, you may wonder why I didn't put devices in there, because essentially a device is stupid. It's dumb. The application is the intelligence that illuminates that device. So there's really only 2 flavors of intelligence in an enterprise. It's either human intelligence or machine intelligence, and machine intelligence is applications. So I know plenty of organizations that like to talk about the device at being at the root of the policy, but really it shouldn't be. And I'll show you another reason why it shouldn't be. It really needs to be the intelligence, which is either the user or the application. And if you flip that around, the intelligence that is attacking you is also either human intelligence or machine intelligence. Nobody got attacked by a chip. What gets attacked is the intelligence executing on that chip, doing something. All right, so great. We've just defined all of cybersecurity policy for the ages. Users and applications can only do what they're supposed to do. Another way to look at it, and a lot of people like to bring this up because this is several decades old, the whole concept of confidentiality, integrity, availability. Stuff is hidden that needs to be hidden. Stuff is available that needs to be available, and stuff is protected that needs to be protected. I'm putting this in here because many of you have probably grown up with this concept. I've never found it particularly useful in constructing an architecture, but it is a way to think about things. Another way to look at things is this notion of authentication and authorization, which is who can see what, and again, who is a user or an application. C is literally being able to observe and steal data, capture data, but there's also change or invoke things. So launching an executable, making a change to a record in a database, who can change that? So there's kind of in a very fundamental sense, you can either read something or write it. You can either see it or make changes to it. And oh, by the way, you might be, as I said above, either a user, human intelligence, or an application, machine intelligence. So really, in some sense, you can say, okay, cybersecurity policy is all about instantiating appropriate authentication and authorization. Who or what can see or change or invoke what? Great. There's some problems with cybersecurity policy, which I'll get to in a little bit. But let's move ahead. What is cybersecurity knowledge? How do you know what's going on in your environment? Well, it's really data and analytics. Data is things like logs, records, alerts, any data that's being generated by any device in the environment, any Simple, I guess the best way to put it is passive information. You have to go and do something on it. Analytics is active information. You may have tools that report anomalies or intrusions or provide insight into what people are doing. So in some sense, there's the big universe of passive data that gets generated by your organization on a daily, day-by-day, hour-by-hour, minute-by-minute basis. And then the analytics, which is the information, the active information that comes from assessing all of this data. And those are important to distinguish because you have different tools that do different things in each of those categories. So that's cybersecurity knowledge. What about enforcement? Well, mechanisms for enforcement, this is not a comprehensive list, but it's a high-level list. It's things like passing or blocking traffic. There's an entire industry built on the whole concept of network cybersecurity, which essentially says you don't get to go here if you're not allowed. And in fact, with the advent of the zero trust model of cybersecurity, companies are flipping the old version of network engineering on its end, and they're saying, instead of saying all traffic can pass except for bad traffic, they're flipping it around and saying only pre-authorized traffic can pass. And by traffic can pass, I mean things like sessions can be initiated. So if you're not authorized, you can't launch a session. Too bad. That also means you can accept or decline requests to access resources. Again, accessing a resource is a high-level way of seeing what's going on in data, launching an application, or it could be as simple as a microservice calling another microservice. Is this microservice allowed to call another microservice? Permitting and shutting down executables. Is this code allowed to run? Where is this code allowed to run? Under what circumstances is this code allowed to run? When is traffic in transit or data in transit, which is traffic, or data at rest, encrypted? Who can see it? When can they see it? When and where are users quarantined, which is kind of a sort of taking a very high-level view that says you can't do anything. You're living in a sandbox until we decide what you're allowed to do. As I'm talking through this, you can see that there's a whole host of fragmented mechanisms out there. So, for example, firewalls do an awful lot to pass and block traffic. They worry about accepting and declining requests for web-based and network-based resources, but they're not so great at, for example, telling you which records you can access in a database. Data cybersecurity can do things, and application cybersecurity can do things like tell you what executables you can run, what can be run, what needs to be encrypted, what data can be accessed by whom, but it's all instantiated in different products that may or may not be talking to each other, which is that main problem that we highlighted. Finally, there's the concept of cybersecurity scope. And honestly, if there's one thing you take away from this session, I hope it's an expanded view of your cybersecurity scope. Because in a very real way, you want to be thinking about data, applications, and infrastructure and hardware, regardless of where it resides. So when we throw data up here, data can be structured or unstructured. Are you talking about files or are you talking about databases? It can be multimedia, it can be text, it can be control data, it can be a huge range of data. One of the things you really need to do as you're building your architecture is get a comprehensive list of the kind of data that you have in your environment and what kind of security you currently have in place and where it's getting implemented, because your goal will be to streamline and rationalize this. Similarly, applications are going to evolve as application architectures evolve. So as everybody starts moving towards a DevOps model, people are moving towards services and microservices and containers. Well, now you have to actually start thinking about securing your services and microservices and containers. And I mentioned earlier, for example, you want to authorize and authenticate microservices to each other, which, by the way, most people don't do yet, even though there are standards to enable you to do that. And then when it comes to infrastructure and hardware, you've got compute resources, you've got network resources, you've got chips. One of the big interesting areas right now is the degree to which there's embedded security in IoT devices and chip level and BIOS level security in devices. So that's a whole new emerging area, and that's kind of bracketed under those devices. So these are some of the things that are in scope for cybersecurity. Obviously, things that are out of scope are a little bit broader, but in general, an example of something that's out of scope is, say, the company's overall risk stance. The cybersecurity risk needs to be aligned with the business risk stance. So essentially, if the argument is, as a company, We will do things that are risky when the benefit of the risk substantially outweighs, the risk itself. That's one stance, and cybersecurity should align with that. Yes, we're going to permit this kind of traffic because the benefit of permitting it is significantly larger than the risk of permitting it. But some companies are more conservative, and they may say, unless it's overwhelming, it can't be significant, it has to be overwhelming. So risk stance would be an example of something that's actually outside of cybersecurity, because cybersecurity feeds risk assessment. So let's get to the meat and the heart of everything. What does your next generation cybersecurity architecture look like? I'm going to warn you, you're expecting an eye chart with lots of complicated, tangled interconnections. You won't see that, and there's a reason for that. You've essentially got your three components, enforcement, analytics, and policy, up at the top as functional elements. Then you've got a set of resources which are located in various places, so cloud, your mobile device, your IoT device, on-premise devices and systems, remote, meaning either branch office or home office, depending on your organization. You may have a series, your mileage may vary. You may have a series more here, but the key point here is that your resources in a modern environment aren't just an on-prem enterprise set of resources, which is the way we all tend to think, because cybersecurity grew up in an environment where we were talking about protecting the enterprise, which implicitly meant you are protecting devices in a particular facility that's owned by the company. That's no longer the case. Your resources are truly virtualized. Any given resource can be living on the cloud. It can be living on a mobile app on a mobile device in somebody's pocket. It can be on an IoT sensor thousands of miles away from you. It can be on-premise, which is the old school way of things. It can be in a remote or branch office. So in a sense, one of the key notions is that you've expanded the definition of enterprise well beyond premise. Back in the old days, as in last year, a couple of years ago, most companies thought of premise-based cybersecurity as the end-all and be-all that they needed to protect. And the key point here is you've got a whole portfolio of locations that you need to protect resources in. And oh, by the way, they're connected by, I have a simple network here. Actually, you have multiple networks. In fact, if you look at IoT security all by itself, IoT actually has 3 separate networks or more, one for the control system, one for the sensor system, and one for managing the IoT infrastructure. Each network could be a combination of wired and wireless, linking the analytics to the end devices. So just because this is a simple line doesn't mean that as you drill down and double click on everything, you aren't getting to more and more granular detail. But starting at this point and looking at it is a good way to sort of boil everything up. Last but not least, the resource types include things like, and again, your mileage may vary, data. I've got a database there, but it could be equally unstructured data, your little application triangle, your microservices, your containers, all of that could exist anywhere in any of those blue boxes. So the point is, I didn't want to replicate them because it would have been an eye chart, but you could have data in the cloud, you can have apps in the cloud, you can have microservices and containers in the cloud, or on your mobile device, or in your tiny little IoT device, on-prem, remotely. So each of those things is going to be, all the resource types are going to be located wherever your resource locations are. Last but not least, you may be looking at this and thinking 2 things, at least I hope you are. The first thing is, how come enforcement has little green stars everywhere, but analytics and policy don't? Because presumably, enforcement touches all of this. You have to have enforcement in the cloud, enforcement of the mobile device, enforcement of data in the cloud, enforcement of data in the mobile device, and so on. But don't you also have to have analytics distributed? My short answer is no. It really depends on the type of analytics you're putting in place. In general, there's going to be some degree of agents living out in most of these places, but not necessarily all of them. However, you do actually have to push enforcement out to the edges as much as possible to embed security across the infrastructure. And then policy is a really tricky one, and we're going to talk about that in just a second, as a matter of fact. One of the biggest challenges with policy is you can't go out and buy a policy engine. Be really nice. Most security policies, when I ask companies, what's your cybersecurity policy, they give me a giant Word document that's like 800 pages and was last revised in the spring of 2017. And there is absolutely no automation and no integration into the actual physical environment or physical and virtual environment it's supposed to protect. I mean, how do you get from words on a Word document to, a machine making a decision about whether or not to permit particular IoT traffic into a particular IoT analytics engine 1,000 miles away? You don't really. Some human has to read that policy and figure out a mechanism by which to implement that policy, which is at the heart of most of the challenges most of my companies are dealing with today, because you're taking a static document that really only exists in the heads of the security engineers and turning it into a process, and that doesn't work very well. We'll talk about really what you need to do, but the other problem is you may be able to automate components of that policy. For example, someone I mentioned Palo Alto earlier, they have a wonderful policy engine for network security, and in fact, network and moving up into application security. That's why it's a next generation firewall. But it can't cover all of application and data security. It's not going to be specific to, say, IoT security, but it's a good start. So if you want to kind of combine a bunch of security policy components using Palo Alto as your engine, that's a good way to do it as a start. But you will also have policies in your cloud access security broker. So let's say you're using Symantec for that. You're going to have to manually integrate Symantec and Palo Alto because guess what? They don't talk together, which is a shame. They really should. So that's the big challenge with policy. With analytics, you can, in fact, go out and buy various analytics engines. The problem is, again, they're not comprehensive. So you can get what we call behavioral threat analytics, that's BTA, and we'll talk about that in a little greater detail, that really serves, in a sense, as an analytics engine, sucks in information from every data source that's out there, logs and audit trails and anything you want to feed it, and then provides insight into the environment. So you can do that, but every company and every product is also building in its own embedded analytics. And while there are good interfaces between analytics engines and data sources, there are not good interfaces between the analytics of various products. So you can't necessarily combine the analytics in your firewalls with the analytics in your web servers with the analytics in your IoT devices and actually get meaningful information. So you can integrate at the data level, but not necessarily at the analytic level. And then, of course, enforcement. Well, if you don't have this level of integration, it becomes really difficult to automate enforcement, which means you're vulnerable. Because what you want to be able to do is detect a policy violation immediately, detect quickly, respond to it immediately, and shut down that violation right away. That's very hard to do when everything isn't fully integrated. So these are some of the challenges with your architecture. Now we're going to switch gears and talk about some key products and technologies that enable some of the different functions. I'm going to go through these fairly quickly. I just want to sort of highlight some product areas and strengths and weaknesses in those areas so you can kind of understand how they fit into this broader architecture. So one example, we talk about protecting applications, particularly in development. One key bellwether technology that we've seen associated with successful security organizations is automated application security testing, so that it really enables you to ensure that your application is secure before you even put it wherever you're going to put it, whether it's out in the cloud or on the premise or in the mobile device. So companies include, things like companies like Contrast and Fortify and Veracode and newer players like Waratech. So if you're looking at application security as one of those components, remember across that broad range of locations, AST is something to be looking into. Container security, to the extent that your environment depends on containers, whether they're in the cloud, on-premise, or microcontainers in mobile devices, or wherever they are, you want built-in security to protect those. There are companies that now specialize in container security. So folks like Layered Insight, Aqua Security, and Twistlock, which honestly has the best name because Twistlock comes from shipping containers. Twistlock is actually the way you stack shipping containers. They use twist locks at the corners. So very clever name there. Then there's, I mentioned earlier, behavioral threat analytics. This is software this is, in a sense, an analytics engine. This is software that integrates lots of sources of data, so logs, analytics platforms like Splunk, to capture and display anomalies. So what behavioral threat analytics does is figure out what's normal for your enterprise and whether there's something weird going on. These are companies like Bay Dynamics, GuruCall, Exabeam, and Splunk itself actually acquired CASB a number of years ago. Analytics engines are extremely important. They can become the core of your analytics function back in that diagram, that big yellow blob. But you really need to choose that technology well because you don't want to have lots and lots of analytics engines for all the reasons we talked about. Advanced endpoint security. This is a little bit funky because this is also a Bellwether technology that's associated with successful security operations, but the reason I call it funky is because, in a sense, you shouldn't have to be thinking about whether your application is operating on an endpoint or even what you mean by an endpoint. But practically speaking, the notion of a device that has a direct interface with the user and is operating far away from data stores such as clouds and servers and virtualized servers, that's an endpoint. IoT can also become an endpoint. Mobile devices are increasingly becoming endpoints. So advanced endpoint security is software that protects the endpoints from malware, not by whitelisting and blacklisting, but actually by providing a lot of that enforcement that we talked about earlier, by containing applications and executables. There's a whole slew of vendors out there that pioneered this space: Bromium, CrowdStrike, Invincia, Tanium, Carbon Black, and then most of the traditional vendors have now jumped into this space, so Sophos, Symantec, McAfee, Trend, all those good guys. Network access control. This falls into that category of authentication and authorization at the network layer. This is also associated with security operations that are at the top, highest percentiles. Companies like Cisco, Forescout, TrustWave keep you from getting on the network based on the security policy. Again, the network security policy, because there isn't an overarching security policy. CASB, I mentioned this earlier. This is on-prem or cloud-based software that figures out what your users are doing on the cloud, and in some cases will stop them if they're not allowed to do it. CASB is an absolute must-have for your cloud resources. If you're doing cloud, you should be at least assessing CASB. The challenge, and many companies are starting to wrestle with this, is you want CASB-like functionality across all of your resource locations, so you should be able to apply it to on-premise resources, which right now many of the CASB tools don't do particularly well. So that's a weakness there. And as you'll notice, we've kind of jumped from high-level functions, application security, container security, which are orthogonal to the location of the resource, to location-specific security, which is much as possible you want to get away from, but at the same time, that is the reality of the environment right now. A lot of security tools have been built up to be tightly coupled to location. A cloud DLP. This really is a little bit less coupled to the cloud location than CASB, because it is usually an extension of on-prem DLP. So it protects content stored on clouds and often on-prem as well. Vormetric is one of the big ones there. SkyHigh, which is also a CASB, does this. And in fact, we're seeing a convergence of the categories of CASB, behavioral threat analytics, and DLP, which sounds kind of weird because CASB is about protecting clouds. Behavioral threat analytics is about worrying about what users are doing and users and systems are doing. And the DLP is about protecting data. But if you think about it, it's kind of like three blind men and the elephant. These are all different ways of looking at the problem. Is someone doing something to a resource that they shouldn't be? So that's why we're seeing that convergence. And finally, there's single sign-on as a service. The notion here is to be able to implement enterprise-wide access and authorization to resources regardless of where they are, living as a service so that it can be to on-prem resources or cloud-based resources. A lot of our companies are rolling out Microsoft, Okta, or Ping for this. So we've gone through this in a big, high-level, fast, run-through. Now, you've looked at this and you say, yeah, it all makes sense. We got the bubbles, we got the arrows, we got the connections, but what do we do? Where do we get a cybersecurity architecture out of this? And by the way, why didn't you give me an architecture that I could just go use? I'll answer those in two separate questions. First, when you go and start building your cybersecurity architecture, the first thing you really want to do is take a look at what you've already got and what's out there and set your foundational tools for policy. So where do you want most of your policy to reside? And when I say foundational tools, what I mean is there's no such thing as a policy engine. I've said this a million times, but there are tools that will capture and automate a lot of your policy. Do you want that to be in your, in your cloud access security broker? Do you want that to be in your next generation firewall? The answers are going to be individual to you. It depends on what technology you've already deployed, what technology you're planning to deploy, what you've got in-house and what's gotten integrated, what you're planning to integrate. But think about, to the best of your ability, where do you want the canonical definition of your policy to live? It won't be perfect. There will be aspects of your policy that don't live there, but at least you can say, okay, if there's any questions about what the policy is, it's what we built into whatever the tool is. So think about your policy first and where it's going to live first. Then start thinking, you probably heard this word a lot, about integration. You want to really make sure that there's integration between any of your tools that are instantiating policy. Now I've switched from a singular policy tool to plural policy tools because, as I said, there simply isn't a God box for policy. So you're going to have your policy instantiated in a range of, in a range of applications and network devices and compute devices. Well, first and foremost, these policies should be talking to each other. So if you update or change a policy on one, to the best of your ability, you've been able to update it and change it across the board, so that if you, for example, make a policy that user X can no longer access resource Y, your firewalls now know that certain sessions are set up, can't be set up anymore, or whatever it's going to be. So make sure that those policies integrate. And then you really want to integrate between the policies, the analytics, and the enforcement. And that requires a whole lot of integration effort because, as I mentioned, the analytics tools tend not to integrate too well with other analytics tools, but they do integrate really well with each other's data. Enforcement is, again, just a grab bag of integration. So you're going to want to think about which tool are we using for policy, which tool are we using for analytics, which tool are we using for enforcement, and then turn off that functionality in the tools that you aren't using for that level, because otherwise having things turned on creates vulnerabilities. And then push your vendors towards this concept of an ecosystem and pre-integrating. Earlier, I raised the fact that Palo Alto and Symantec don't talk to each other. That's too bad because quite a lot of companies have selected Symantec, particularly its CASB and Advanced Endpoint Security, as kind of foundational policy tools for cloud and desktop, and they've selected Palo Alto for next generation firewall. Ideally, they would talk together. If you are one of those companies that has both and consider both to be strategic vendors, get them in a room and smack their heads together until they decide to integrate. And as a sort of a definitional exercise, you should surely make sure that when you purchase a new product, one of the requirements for that product is that it's integrated or pre-integrated with the products you've already got. So this comes back to the notion of using your architecture as kind of a framework to decide what to buy and what not to buy. If you've now made the decision that a core policy engine is vendor X, then anyone that integrates with vendor X should get a checkbox or check mark in your assessment because integrating with vendor X is necessary or highly desirable in your rating. That's actually really important because I see a lot of people still going through and assessing security products on a point basis. So one of the things you really want to do here is make sure that the output of your architecture is selection criteria such as the ones that I've described. Finally, again, biggest thing, if you walk away from this with nothing else, decouple the concept of a resource from the concept of the location it lives in. You can think about data, but try not to think about cloud data or mobile data or on-prem data or IoT data because the same data is going to potentially move from location to location, and you really shouldn't be buying tools that protect the data differently regardless of where it is. Obviously, or differently based on where it is, excuse me. Obviously, the vulnerabilities are going to be different, so you want cloud-specific protection for when that data moves into the cloud, but you don't want to buy cloud data protection that then the protection ends at that cloud, and when the data leaves, it's no longer protected. You want to think in terms of how is that data getting protected across, across all the locations. And that's just data. You can talk about infrastructure, hardware, applications, services, microservices, containers, and everything else. So bottom line is you want to think in terms of protecting all resource categories regardless of where they are. So those are some of the fundamental principles you will use to build a cybersecurity architecture, and that's why we're not handing you a complete fleshed out architecture with core technology areas and integration built in, because it's going to depend very, very heavily on your particular environment, the degree to which you have different resources in different locations, and some of the selections that you've already made in terms of where you're doing your policies or where you want to be doing your policies, where you're doing your analytics and how you're doing your analytics, and where and how you're doing your enforcement. But at least if you start with those concepts in mind and ask yourselves the question, what's my core policy engine? What's my core analytics engine? How am I enabling enforcement across my heterogeneous environment? You can make some really good headway towards crafting this architecture. Last but not least, we can help you. We can take you a lot farther along this journey than we've done here. We have a couple different offerings that we use for enterprise organizations. One is a security maturity model assessment that's a quick hit assessment. It's a shrink-wrapped consulting gig that essentially says, here's where you're weak, here's where you're strong. We look at everything from where you're making your investments to how much you're investing to what tools and technologies are in your organization, and can give you kind of a heads up, a thumbs up, thumbs down in terms of, do you have the right technologies on your roadmap? Do you have the right roadmaps, et cetera? That's short and sweet. If you want us to help you build that architecture and align it with your strategy, we can do that too. That's a more traditional consulting engagement that's kind of open-ended, but we certainly go in and help clients do that as well. With that, I think, Erwin, I am handing back over to you for the wrap-up.
Help if I took mute off. Thank you, Jana. And before we get to our Q&A period, I want to draw your attention to the Attachments tab. In there, you will see a link to the Nemertes Unified Communications Cost Analysis Tool, which is an interactive online tool that will give you real-world, organized, customized cost data to help you select the best UC architecture and provider for your organization. And I'll also like to, I'll put up our contact information. I'm going to put this up again once we get past Q&A, but you'll see this for now. Let me go ahead and jump to the next one. We talked about the Nemertes UC Cost Analysis Tool. And our next webinar is WAN Economics, the business of disrupting your WAN, which will be presented on Wednesday, September 19th by Nemertes CIO and Principal Research Analyst John Burke. You can register for that webinar simply by clicking on the registration link. Again, you'll find that in the attachments and links. And Jana, do you want to talk real quick about what folks can expect on that webinar?
I will, and thank you for the opportunity, Erwin. One of the really interesting things that we've been seeing is the shift away from sort of prepackaged services like MPLS towards SD-WAN and similar services. What you will see as part of that webinar is what you're paying for, what other companies are paying for various services across a range of global regions, how shifting to SD-WAN can potentially save money, and which services are the best bang for the buck, or bang for the euro, or bang for your local currency here, based on how the bandwidth and the availability of them. We also look at, and I'll stop, but really, we also look at things like install times and availability and uptime for different carriers across different regions. So there's a whole lot of great insight into how robust and reliable and cost-effective your next generation WAN can be.
Excellent. Thank you, Jana. And let me go ahead and jump to one more slide. We do have some research that's underway. If you're interested in participating, Jana has mentioned we have a cloud and cybersecurity study that we're currently looking for participants. So if you're willing to get on the phone with us for about an hour for a confidential interview, we will give you access to the results of that study. We do not share your name or company information, so that is anything that we publish, it will be completely anonymous. So if you're interested, again, please click on the attachments and links, and there's a form to fill out to participate. And then we'll be conducting, Jana will be leading a study on IoT starting in October as well. And same thing, if you're interested in participating in a confidential phone call, please click on the link and we will get you signed up for an interview for that as well. And then let's move on to our last housekeeping slide. Nemertes Navigator 360 Conference 2019, scheduled for May 20th through the 22nd at the Don Cesar Resort in St. Pete Beach, Florida. This is focused on digital transformation 2020 to 2025, emerging technologies that will drive business value. So we'll be sharing some of the results of the studies we just mentioned, as well as some additional deep dive information into how organizations can successfully develop digital transformation strategies. And please feel free to consider, free to join us. We'll highlight the top technologies you need to consider for your organization for the next 5 years and beyond. And as we go ahead, like I said, I'll put the contact information up. If you have a question, please go ahead and submit it using the BrightTALK panel, and we'll get to those as fast as we can. I do have a couple of questions here, Jonna, so let's go ahead and start. First one, you went through a great discussion of foundational tools, and you talked about some of the components of the tools that are required for managing a cybersecurity architecture. You kind of said that there's a lot of overlap and vendors that don't talk to each other very well. Are there anyone developing or any standards bodies working on kind of a framework that would allow an organization to develop centralized policies that would enable consistency across the areas that you talked about earlier, like IoT and mobile and cloud and so on?
Not really. This is a great question, Erwin. And of course, everybody says, "Oh, I know the NIST framework." But the problem is NIST framework is very high level and talks about some of the key things that you need to think about. What you're more likely to see is either point standards, such as a standard which escapes me, but I think it's an IETF standard for things like microservices authentication, that are happening in particular areas, and IoT has its whole universe of point standards, or one-on-one integration that's happening among vendors and their ecosystems. And so what you're starting to see is some coalescence between the big vendors. So I mentioned Symantec earlier. They, for example, they have plenty of analytics, but they don't specialize in behavioral threat analytics, so they built out a nice little API integration, pre-integration with Bay Dynamics, which is one of the BTA vendors. So these are the kinds of things that you're starting to see. There isn't really a holistic framework that says, we're developing standards for integration for all of this.
Excellent. And second question that came in, what are your top three things that your clients top three issues that your clients tend to have when it comes to cybersecurity architecture? What are we seeing as their biggest barriers or obstacles to developing an effective architecture?
The first one is not having an architecture at all. And sorry, I have to bring it up because a significant percentage of folks say, I don't need an architecture, I just need to have the tools to do what I need to do. And unfortunately, architecture is the gap between fully understanding what you need to do and having those tools. So that's the first one. Second one is having an architecture that sort of makes implicit assumptions about the environment that it's supposed to be protecting, usually that the environment is on-prem, and doesn't include key areas. So in particular, in our research, even leading edge companies tended not to have a cloud security architecture, an IoT security architecture, or something very close to home for you, a unified communications or collaboration architecture. In fact, in our most recent round of research, we had the pleasure of asking people very specific details about how they were protecting their unified communications and collaboration environment. And most of the time, the cybersecurity folks had no idea. They had literally never considered that as a class of applications they needed to protect. So that's the second, that's the second big concern. I think the last one is that many times for cybersecurity, the architecture includes a whole lot of things that are interesting but not as relevant as I would consider. It's not really as detailed technically as it needs to be. So in a lot of cases, people will say, well, we have an architecture, but it's more about policy and process and less about technology. And right now, when companies are spending, tens of millions of dollars on overlapping and redundant tools, you really need to think about your architecture at a technology level.
Yeah, definitely. And you know, again, you can't have an effective security, as you mentioned, if you're not thinking about it from that architectural model. And then once we have the architecture, this is something I've always worked with, I've seen organizations struggle with around network architectures. How do you move from that architecture to implementation? What are the steps that you take to actually implement and move from the architectural view to more of a tactical, step-by-step implementation view?
That's a great question, and I'll give you the sort of platonic answer and then the real-world answer. The platonic answer is you look at this and you say, oh, cool, I've figured out which functions I need and sort of where I want those functions to reside. Now I just have to sort of wrap a timeline around that and decide, what do I have? Do the gap analysis. What do I already have? What's actually missing? And when am I going to go buy the stuff that's missing, and then move smoothly from that architecture to your roadmap, which is essentially just a project plan, a high-level project plan for bridging that gap. I can finally find the right word, bridging that gap. That's the platonic idea. So here you have these beautiful slides. They tell you everything that you're going to be doing. You turn it into a roadmap that tells you when you're going to be doing everything that you're doing, and then you just go out and execute on your procurement test, integration, rollout, et cetera, et cetera. In the real world, in a lot of cases, simply figuring out what is in your environment is almost overwhelming. And so sometimes projects that we work on with clients include things like looking at doing almost a matrix view of functionality against products that are in place to uncover areas where things are highly redundant and actually start taking away stuff so that you can free up the resources to roll out new stuff. So you actually have to almost upend it, figure out what you've got before you can figure out where you're going. And that's kind of an interesting project that we do a lot of. So that's another piece. You may be in that mindset where you've got too many people and too much stuff, and it's almost like having an overstuffed closet. You can't begin organizing until you take it all out, lay it out there, and say, look, why do I have 57 pairs of black jeans? I need one, right, or whatever.
Yeah, so building, and as you mentioned, we've done this with a number of clients where we're typically looking at sort of current state, where the gaps are, where the need is to fulfill the goals of that architecture, and then how do you close those gaps. So you mentioned that we have the opportunity to help clients develop an architecture. Can you tell us a little bit more about kind of the kinds of opportunity or the kinds of services that we've delivered?
Yep. Absolutely. I think we've covered a lot of that, but just to be clear, we'll come in, we'll do a quick high-level assessment to understand really what's in your environment, and then drill down. We will conduct some of these things that we've talked about here, so if there's overlap, we will assist you in that process, which is actually very labor-intensive, of figuring out where you've got duplication and overlap. We'll also make sure that most importantly, that you've covered all the key areas, because in general, what most companies struggle with is blind spots, as I mentioned earlier. There are areas that they just didn't think about. I mean, we went and developed an architecture for a company not too long ago, and they realized they had no overarching IoT framework. They had no integration between their cybersecurity architecture and their IoT cybersecurity architecture. And yet they were doing IoT. They were probably one of the more advanced organizations when it came to rolling out IoT. So those are the kinds of catches that we make, and make sure that we can actually get that all on the same page literally, and that people have a plan to move forward that then goes into the very detailed work of vendor selection, vendor comparison testing, and then moving into operational mode.
Excellent. And we have one last question. Are there certification courses that you recommend for folks that are interested in working within their own organizations to develop enterprise cybersecurity architectures?
I'm sorry, repeat the question?
Are there certification courses that you recommend?
Yes. No, and this is actually frustrating. I think the only one, this is not a helpful answer, and I feel sorry for the person who asked this, because I kind of went, I wish there were one. Most companies go for ISSC. I'm CISSP. I'm not in love with that, but it is about the most general and across-the-board certification that folks get. I would actually recommend more, if you're going to get certifications, probably, this is going to sound goofy, But the best thing you can bring to the table is actually a solid knowledge of programming tools, because even though that's 3 steps down from architectural, that's actually kind of critical in being able to implement the architecture, and it's one of the gaps that many of the security architects actually have. They don't understand what's possible and limiting in programming because they don't have programming chops. So if I were doing more hands-on security today, I would probably be beefing up my programming capabilities ahead of getting formal, CISSP certification.
Yeah, I think that's great advice. I have my CISSP certification, and it's very broad and not very deep. So certainly some of the areas that you look at, I think you'd want some additional, more detailed knowledge. And then again, as we talked about, building those connections between different systems will certainly require having a fundamental programming understanding. So with that, we are out of questions. Jana, thank you so much for your insights, and thanks to everyone who submitted questions and who took the time to attend today. Again, a webinar replay will be up on our channel shortly. If you found it valuable, please feel free to share it with your colleagues, and please take a moment to rate and send us feedback. It's much appreciated, and we do look at that feedback for input into future webinars. If you haven't already, please check out the links in your attachment tab, and do check back often. We post new content to our BrightTALK channel on a regular basis. Thank you so much for joining us today, and this concludes the webinar.